Everyone, so last time we have learned how the latent image is formed. So, ano nga ba yung latent image? It is the image on the radiographic film after the exposure prior to processing. So, is it visible? No, not yet, unless we process this film to have the manifest image. So, yung visible sa ating radiographic film is the manifest image. So for this video, we will learn how this latent image can be developed into a manifest image. So this is the system of film processing. So processing is as important as technique and positioning in preparing a quality radiograph. So as a radiographer, you should know how to position the patient properly for every procedure and select the best technical factors that could be used to our patient. So bilang radtech, kailangan maayos yung pagpo-position sa pasyente and pagsaselect ng technical factors para magkaroon tayo ng diagnostic quality radiograph. Pero hindi naman pwede na dun lang sa dalawang yun ka lang magaling. So, it means na there could be cases na maayos yung position mo, maayos yung technical factors mo, pero nagkamali ka sa film processing. So, ganun kahalaga yung ating processing sa ating radiograph. So, for the film processing, we have two types of processing system. We have an automatic processing and a manual processing. So for now, let's talk about an automatic processor. So this is a device that has roller transport system and it comprises chemical tanks. So this is a machine na yung mga chemical tanks ay nasa loob nito and composed of transport system or of rollers. So kay automatic processor, ang ginagawa niya is doon natin siya i-feed yung radiographic film na na-exposed and lalabas siya ng machine na yon na meron ng manifest image. Okay? So with the help of our roller transport system, it could pass through the different chemical tanks and will exit the machine with a manifest image. Actually, it will exit the film dry with a manifest image. Again, so anong ginagawa ni automatic processor? We will feed the exposed film containing the latent image into the automatic processor, and with the help of our roller transport system, it could pass through our chemical tanks that will develop our latent image into manifest image, and then it will exit our machine with a manifest dry radiograph. So just a short history or just a brief history of an automatic processor. The first automatic processor was introduced by Pako in 1942. So it could process 120 films per hour with the use of special film hangers. So yung kauna-unahang automatic processor ay wala pang rollers. They use a special film hangers. So by 1956, the Eastman Kodak Company introduced the roller transport system. So dito kay 1956 na roller transport system, there is no use of special film hangers kasi meron na tayong roller transport system. This roller transport system helps our film to pass through the different chemical tanks. So, yung total cycle time for processing one film noong 1942 was approximately 40 minutes. Sobrang tagal ng processing time niya. Therefore, noong 1965, again, the Eastman Kodak developed another automatic processor which have a 90-second rapid processing. So, yung 90-second rapid processing, the moment na nag-feed tayo ng exposed film sa ating machine. Within 90 seconds, lalabas yung ating image or yung ating dry film na nagko-contain ng manifest image. So, pinabilis ni Eastman Kodak noong 1965 yung ating processing. So, sabi ko nga kanina, ang automatic processor is a device that has roller transport system. So, paano nga ba gumagalaw yung ating radiographic film sa loob ng isang automatic processor? So, first we have the feed tray. So, this is where the transport system begins. Dito natin inilalagay yung ating exposed film containing the latent image. So, kapag naipasok sa ating feed tray ang ating radiograph film, kakainin siya or igigrip siya ng ating entrance roller. So, entrance roller will grip the film to begin its trip to automatic processor. So, there is a microswitch control at the entrance of our automatic processor that controls the replenishment rate of processing chemicals. So, ano ba yung replenishment rate? Or yung replenishment? So, since it is an automatic processor, yung chemical tanks nasa loob. So, the replenishment, kailangan umiikot yung ating mga chemical solutions or nagre-restock yung ating chemicals sa loob para hindi siya maging stagnant. Kasi kapag naging stagnant yung ating mga chemicals, nagkakaroon ng pagbabago sa kanyang activity. So, therefore, kailangan natin ng microswitch para mag-replenish yung mga chemicals sa loob. Umikot, mag-restock para hindi mabago yung activity ng ating chemical solutions. So, transport system not only transports the film, and it also controls the processing by controlling the time the film is immersed in each wet chemical. So, the transport system, hindi lang basta nagpapass or hindi lang siya tumutulong sa film na mag-pass through the different tanks, but this also controls the time. Kung gaano katagal mag-i-immerse yung ating radiographic film sa bawat chemical tank. Okay? So, the transport system have three principal subsystems. First, we have rollers, and then transport rack, and the drive motor. So, rollers. Rollers supports the film movement. Pag sinabing rollers, sila yung nag-hold sa ating radiographic film para umikot sa loob ng ating automatic processor. We have a transport roller that will convey the film along its path. So, transport, siya yung nagtatransport sa ating film. It has a diameter of 1 inch. Okay, so these are positioned opposite to one another in pairs or naka-offset siya from one another. Then we have a master rollers. These are used when the film makes a turn in the processor. So for the between chemical tanks, we have a master roller. So meron sa may bandang ilalim ng chemical tank and meron sa taas ng chemical tank. So, parang ganito yung ating master roller. Okay. So, for example, we have this developer tank, and then wash tank, and then fixer tank. Developer, wash, and fixer tank inside the automatic processor. So, asan si master roller? Meron dito, meron dito, meron dito, dito, dito. para mag-guide niya yung ating radiographic film na mag-turn sa bawat tangke. Okay, so ganun yung trabaho ni master roller. Next is the planetary rollers. So, si planetary rollers, may kasamahan siyang metal or plastic guide. Yung tinatawag nating guide shoes. These are usually positioned around the master rollers. So, on this image, makikita natin si master roller with a diameter of 3 inch. Sa kanyang gilid, meron tayong guide shoe. So, si guide shoe, it could be formed by a metal or plastic. Sa gilid ng ating guide shoe, merong planetary roller. So, sinusupport nila si transport or si master rollers sa pag-ikot ng ating radiographic film. Okay? So, those are the 3 types of rollers na makikita sa ating automatic processor. Next, we have a transport rack that moves and changes the direction of film via rollers and guide shoes. And then we have a drive motor that will provide power to turn the rollers at a precise rate. Okay, so inside our automatic processor, we have a thermocouple or thermistor to monitor the temperature of our chemical. So this is controlled thermostatically by a controlled heating element in each tank. So why should we monitor the temperature of our chemical solutions? Especially the development or the developing solution temperature. This is the most crucial or this is the most critical temperature na dapat i-maintain. So, it is usually maintained at 35 degrees Celsius or 95 degrees Fahrenheit. Kasi kapag tumaas ang temperature ng ating developer solution, its activity will also increase. Okay? Pag sinabing the activity also increase, mas mabilis siyang mag-develop kapag mas mataas yung kanyang temperature. Kapag naman bumaba yung temperature ni developer solution, babagal din yung kanyang activity. In my case, may naging experience ako na hindi ko na-check yung temperature ng developer, bumaba siya sa dapat na temperature niya, which is 35 degrees Celsius. So, ibig sabihin malamig yung developer solution ko. And hindi ko siya nahalo. Kasi in my work, we are still using a manual processing. Therefore, mano-mano talaga yung paghahalo sa mga bawat chemical solutions namin sa tangke. So, in the morning, hindi ko nahalo yung aking developer solution. Kasi yung paghahalo or yung pag-agitate ng bawat solution, it also controls or it also help to control na ma-maintain yung temperature ng solution. So, yun nga, hindi ko siya nahalo. What happened on my radiograph? It became blotchy. Dahil malamig yung aking developer solution. Hindi niya nagawa ng ayos yung kanyang job na mag-develop ng ayos ng ating manifest image. So, blotchy, nagkaroon siya ng mga black patches sa ilalim na banda nung x-ray ko. Nasa bottom part nung mismong radiographic film. Blotchy appearance ng mga parang patches ng black. So, that's one factor na malamig yung solution ko. Malamig yung developer solution. Kapag naman mataas yung solution, yung temperature ng developer, mabilis umitim. Mabilis masunog yung development ng ating manifest image. So, the wash water is maintained at 3 degrees Celsius or 5 degrees Fahrenheit and lower. Okay, so that's the temperature control system. Next, we have a circulation system in our automatic processor. So, katulad nga nung nabanggit ko kanina, kapag manual processing, mano-mano yung paghahalo ng mga solution in our chemical tanks. Pero dito, kay automatic processor, meron tayong rollers na magko-continue na mag-mix ng ating processing chemicals or yung tinatawag nating agitation. So, this maintains constant temperature throughout the processing tank. So, this aid exposure of emulsion to chemicals. So, with the help of our rollers, yung ating chemical solutions ay nag-agitate. Kaya nakokontrol din niya yung temperature ng ating chemical solutions. So, circulation system continuously pumps the developer and fixer, thus maintaining constant agitation with each tank. Okay, so for a developer circulation system, this requires a filter. Sa circulation system ng ating developer solution, it requires a filter that will trap the particles na maliliit. So, ano yung mga maliliit na particles na yon? Like, flecks of gelatin. Kasi di ba ang ating radiographic film merong gelatin? So, kapag nagde-develop, nababakbak yung gelatin na yon. So, this could dislodge or this could dislodge from the bottom of our chemical solution tank, especially sa developer. So, circulation system ng developer solution, kailangan ng filter that will trap particles as small as approximately 100 micrometers para matrap to mga flecks of gelatin na to na manggagaling sa ating emulsion. So, the minimum flow rate for the wash tank in most processors is 12 liter per minute or 3 gallons per minute. So, that is our circulation system of an automatic processor. Yan. Okay, so for the replenishment system, as I've said earlier, we have a micro switch at the entrance of our automatic processor. So, si micro switch, ang job niya is magkaroon or maging switch siya para magkaroon ng replenishment sa bawat chemical solution tanks. So, ano ba yung replenishment rate? So, replenishment rate are normally established on the basis of how much chemistry is required per 14-inch of film travel. Ano ang ginagawa ni replenishment rate or ni replenishment system? It restocks the solution for every chemical tanks. So, for developer, ang replenishment rate natin is 60 to 70 cc or 4 to 5 ml per inch. For fixer, replenishment rate natin is 100 to 110 cc of fixer or 6 to 8 ml per inch. So, ang sabi dito, based per 14-inch of film travel. Meaning, ang size ng film na magkakaroon ng replenishment rate or ng replenishment will be 14 by 14 and 14 by 17. So, these are the sizes of film na automatic magkakaroon ng replenishment kapag ipinasok sa loob ng automatic processor. Since nakalagay natin dito is per 14-inch of film travel. Kapag ang size ng film na ginamit natin is 8 by 10 or 10 by 12, there will be no replenishment system or there will be no replenishment sa ating chemical solution. How about 11 by 14? Will there be a replenishment? Yes, as long as yung pag-insert natin sa feed tray is naka-crosswise ang position ng ating 11 by 14. Pero kung ipapasok mo yung ating film na 11 by 14 in lengthwise manner sa ating feed tray, there will be no replenishment. Pero kapag ipinasok mo siya ng naka-crosswise, yan, there will be a replenishment sa ating chemical solutions. So next, to our circulation system, for our automatic processor, we have a dryer system. So, katulad nga na sabi ko sa inyo, pag ipinasok natin yung image na na-expose sa ating automatic processor, lalabas siya na may contain ng manifest image and dry yung ating film. Dahil inside our automatic processor, we have a dryer system. So, ano ba yung nasa dryer system ng automatic processor? We have a blower, ventilation ducts, drying tube, and an exhaust system. So, lalabas yung film natin na tuyo na containing the manifest image. So, what happens or bakit minsan may mga automatic processor na kahit gumagana naman yung kanilang dryer system, may film na lumalabas na medyo basa. Hindi man siya basa like literally na may water pa, pero ang kapal niya sa film ay medyo damp, malagkit yung film. It is because of under-replenishment that will cause or that will reduce the concentration of the hardener. Okay? So, kaya minsan may mga inilalabas yung ating automatic processor na malagkit na film is because of an under-replenishment from our developer solution. Because it will reduce the concentration of our hardener. Kung naaalala sa assignment natin, I've asked you to list down the chemicals for our processing solutions. And as you guys still remember, we have glutaraldehyde as a hardener sa ating developer solution. That hardener is only included when we use an automatic processor, si glutaraldehyde. And also sa ating fixer solution, di ba mayroon tayong hardener din. So, under replenishment will reduce concentration of the hardener, and ang mangyayari doon, even though na nagwo-work ang ating dryer system na automatic processor, the film will result into a damp or medyo sticky yung feeling ng ating films. So, this is the cross-section, or the cutaway view of an automatic processor. So, kung mapapansin, ang ating rollers ay madami sa loob ng automatic processor. So, nagkasama-sama dyan si transport roller, master roller, and planetary rollers. Okay? So, next is the daylight processing. Ang automatic processor ay nasa loob pa rin ng darkroom. Kahit automatic yan, dapat nasa loob pa rin siya ng darkroom. Dahil bawal pa rin ma-expose yung ating film sa white light. Pero meron tayong tinatawag na daylight processing, in which ginagawa siya sa labas ng darkroom or kahit walang darkroom. So, daylight processing system is a method whereby X-ray films can be loaded into a cassette and after being exposed, emptied from the cassette into an X-ray film processor in a normal room lighting without using a darkroom. So these types are of a processing system is yung pag inilagay mo basta yung cassette, para siyang merong puzzle sa ating latches ng mga cassette na siya yung mag-o-open, yung processor na to, siya yung mag-o-open ng latch na yon and kukunin yung ating radiographic film and siya na din yung maglo-load ng film sa ating cassette. Okay, so ang nangyayari sa kanya, nasa labas lang siya ng ating darkroom or sometimes kapag walang darkroom yung mismong X-ray lab, gumagamit sila ng daylight processing. So, siya na din yung naglo-load and unload ng cassette kahit nasa white light siya. So, this is developed by Schmidt of Production Company in conjunction with DuPont and first put into operation in 1969. So, this receives film in 15 seconds and it took 2 minutes for the whole processing. Okay, so this uses microprocessor. Our daylight processing uses microprocessor. So, those are the two processing system na ginagawa bukod sa manual processing. Thank you!